Today in the US, there are more than 1 million international students. And we found that in the TOEFL, which is the exam each international student has to pass in order to study in a US school, the lowest scored section is the speaking. In our surveys, we found that 60% of students use tools in order to understand how to pronounce a word, and only 14% think that these tools are useful. So we have a problem, and we want to solve it by the use of technology.
Testing and doing multiple iterations, we were able to create the final high-level prototype, which had a lot of additional features compared to the original prototype. It had engaging feedback, it had the ability to save words that were mispronounced frequently, and it also had phonetics that were included. In the feedback section, we made it very engaging to the user. There was a lot of encouragement given to the user to improve, like things that said, let's keep trying, or you're getting better. I particularly liked the feedback which showed faces, like a smiley face or a sad face based on how they did, rather than just having a word that said that they didn't do that well.
Having all of these ideas about Athena, next I want to briefly talk about what the technical challenges we faced during the app implementation, and also I want to briefly introduce our pronunciation evaluation algorithms. In this project, our apps have to communicate with different APIs, like Google Speech-to-Text API, Amazon AWS Service, and Merriam-Webster's e-dictionary. So our first technical challenge is how to let our app communicate with all these different APIs successfully and then embedded all this code into our apps. Having solved this problem, next we have to design an evaluation algorithm to let our application say how the user's pronunciation is good or not. So we introduced the definition of Lewiston distance. This means the number of operations when transferring one string into another. So in general, our algorithm works like this. First, our app will upload the user's audio into Google Speech-to-Text API and then get the recognize test. Next, we calculate the Lewiston distance between the recognize test with the user's standard input and use the distance as a contributing factor to our output score expressed in the different face expressions. So that's all basically our main technical challenges we faced during the implementation phase.
I think there are two features that I like the most. The first one is the fact that this app doesn't return the result based on a score scale, but rather an interesting face feature, such as a smiley face, a pouty face, etc. And the second feature that I really like about this app is that it helps you to improve what you have done wrong. So you can actually know which word that you didn't pronounce correctly. And so I think this feature really helps to improve.
I think the app is wonderful. I think you did a really wonderful job. The other apps focus on the single words, but this app focuses on the sentence. So I think this is more practical than the other apps. I think I will use this app before I prepare for a job interview because I think it's really convenient for me to improve my pronunciation right away. And I will use it, I think, several times a week.